Welcome to another Spring Knowledge Transfer event. Thank you all so much for joining us today alongside Spinview, who recently utilised AI and image analysis technology to drive collaboration and strengthen compliance at Welsh Water. So we'll be hearing all about their journey together today on that piece. For those who aren't familiar with Spring, I just want to run through quickly who we are and what we do. So Spring are the Centre of Excellence for Innovation in the UK and Ireland, and our main objective is to enable effective delivery of innovation and collaboration by creating centralised intelligence for both water companies and suppliers. So our mission is to attract, connect and support innovators across the industry to accelerate transformation. And it's great to see companies like Welsh Water already realising value from this, both through Spring's knowledge sharing service and through Spring's part in aligning the sector on Ofwat fund bids. So Welsh asked Spring to lead development of a sector-wide specification for a PFAS analyser. And Spring convened all water companies to co-create and promote the spec, attracting 13 solutions to a pitch day, with one taken forward into an actual Ofwat Innovation Fund bid, which was great to see. This work created a clear, shared view of the sector's needs, paving the way for faster and more aligned adoption. And that's exactly why we facilitate and host knowledge transfer events such as today too. Through these knowledge sharing events, we hope to support the transfer of the learnings from an innovation project to the wider sector, creating project legacy that helps innovators to identify and adopt the right solutions at a greater pace. So last year, we partnered with Ofwat, the economic regulator for England and Wales, to build a view of what best practice knowledge sharing actually looks like. We brought together senior leaders and innovation managers to design a vision for knowledge sharing and what actually is it that we're trying to achieve. Ultimately, we want to unlock faster adoption of innovation by creating a world-class knowledge sharing culture. And so the 6 best practice principles we created to aid in this were: 1, learn from what already exists before committing to innovation projects. And to help this, we created the Spring platform, which hosts a multitude of project case studies aligned to the priorities laid out in our water industry strategy 2050. So for anybody who hasn't seen that document before, hasn't seen our platform before, we will be putting links to those in the chat, and I really recommend you check those out. We are also working on other tools to ensure innovation intelligence is easily accessible to the sector. Our second principle is to target innovation insights to the right audience to meet our objectives. So for example, today, do we have the right people on this call who will be able to take action on the knowledge shared today within their own organisations? Number 3 is insights are regularly shared through multiple channels from day one of the project. So historically, knowledge share has happened at the end of a project, and we really want to start moving towards a model where we share from day one and make sure all of those really valuable insights are captured as we go. The 4th one is sector knowledge is open and centralised. So we want to make sure that we're all being open and honest when it comes to the knowledge from innovation projects. And we want to make sure that it's all in one place, i.e. Spring, because fragmented knowledge is much more difficult to engage with and learn from. Insights from both innovation successes are shared. So as we all know, the lessons learned from failures are just as important as the lessons of success. And we'll be hearing about some of those challenges and some of those successes today from our presenters. And the final one is people are empowered to receive and embed lessons from external sources. So Spring and the presenters on this call can all share knowledge, but we want to make sure that you, the receivers of the knowledge, have the resources and have the capacity required to actually make that change and take action on that knowledge, and that you feel empowered to do so. So please, if you do find any interest in this project today, do contact me and Spring will see what we can do to help in any way with pushing this forward in your organisation. So back to today, I'd just like to give a warm welcome to all the audience members joining us live. We are joined by the UK and Ireland water companies, supply chain, academia, and plenty of overseas colleagues too. So welcome to the call and thank you so much for joining us. As always, we'll be including a poll during this event to gain your thoughts. This is really the most impactful way that you can help us to make sure that these events are providing value to you and your organisation as well as the wider sector, and that these showcases are indeed supporting that faster paced adoption of solutions that we're aiming for. Your insights not only help us understand the actions that you plan to take on the knowledge from today, but if there was any more we could have done or shared to ensure a more successful transfer of the key insights from the project. We'll be launching that poll at the break, so please do make sure to submit your answers when this comes through, and we'll also launch it again at the end for those who didn't get a chance to answer during the break. If you are planning to drop off early, we really would appreciate if you could give us an answer to that poll in the break before you drop off. You'll also get the chance today to ask the project team any questions at the end of the session in our live Q&A session, so make sure to keep putting any queries that you have in the chat throughout today's presentation, and Spring will make sure that the presenters have time to answer those at the end. If not, we will have the presenters provide written answers following the call, which will go on our platform alongside the case study and the recording of today's call. So now I'm just going to run through the agenda quickly and the speakers before we kick off the session. So to begin with, we'll hear from Welsh Water on what the value of knowledge sharing is for them, a little bit of context setting around the project itself, and then the project overview from Spinview. We'll also see a bit of a roadmap and the implementation guide to get from A to B with this project. We'll then hear again about the overall impact for Welsh Water from this innovation project before going into a quick break, followed by some lessons learnt, and finally the Q&A. So just to introduce our speakers before I hand over to the lovely Paul, we will first hear from Paul, Innovation and Optimisation Manager at Welsh Water, Sarah Harries, Innovation Scientist at Welsh Water, Tori Mackenzie-Harvey, VP Customers at Spinview, and Tom Lowe, Head of Data Intelligence, also at Spinview. So without further ado, Paul, I'll hand over to you.
Thanks very much. I'll just move. Oh, there we go. We've got the screen. I'd just like to say thank you for attending. We're really excited that Welsh Water and Spinview can share the outcomes of the project that we did together and the possibilities for the future as well, because as an innovation person, I'm always looking to the future and how we can use things. So I've been asked to speak on why knowledge sharing matters within the water sector. And the first point I want to raise is that it builds expertise across the sector. As you can see, I'm coming towards the end of my career now. I haven't got the hair that I had in the last photo, and it's become all the more apparent to me that as a sector, we need to pass on knowledge to the next generation of budding scientists, engineers, and innovators. So we're in a good place for the future. Secondly, by sharing our knowledge, we can encourage collaboration and innovation. We don't all want to be running the same pilots, the same innovation projects, all in the same area. So let's work together, understand what each other is doing, share our knowledge and avoid duplication. And lastly, by knowledge sharing, it can strengthen our resilience in changing times. And if we share our understandings and our challenges, we can work together to ensure that the water industry becomes resilient for future generations. Unfortunately, I have to shoot off now. I've got some pressing engagements to attend to, but I hope you'll find the time fruitful, and I'll hand over to Sarah Harries, the innovation scientist for Welsh Water, who is going to share more about the project. So over to you, Sarah.
Thank you, Paul. Okay. Hey. Yeah, hi everyone. I just wanted to start off by just introducing myself. I'm Sarah. I work in the innovation team at Welsh Water, and I've been working for Welsh Water for about 13 years now. As a team, we quite often get approached about technology such as digital twins, AI, and what solutions that we can help provide the company with that. So when I started off in innovation, Spinview had already started working with Welsh Water and had started carrying out some spins on our water treatment works. But I met with Tori, and Tori came to site, showed me how to use the equipment, showed me how to upload to the platform, and I must say it was all very easy to use, easy to capture, and once everything was on the platform, it was also easy to navigate. So going back to what we set out to solve, Welsh Water's main driver for wanting to work with Spinview is the development of a 3D digital twin. Welsh Water is a very asset-heavy company with over 800 assets, and there's more than 60 water treatment works because I work with clean drinking water, so this project was mainly focused on capturing clean drinking water sites. One of our main issues is due to the landscape in Wales, travelling between North and South Wales can often take a whole day. It can be very time consuming and travel heavy, which obviously results in a large carbon footprint for us. We've got departments such as capital, the asset planning teams, design engineering, often requiring multiple site visits across the estate, so it's all very carbon heavy. Also within operations, the teams have many challenges which can be helped by using a digital platform. So they have a lot of data to store. So one example where we've tried to use Spinview to help is capturing information that they might hold in the works operating manuals and putting this into the platform so it can be accessed visually very easily. And then another example is the maintenance teams. When you're using Spinview and you can navigate around a site and come across a piece of kit, for an example, a pump, you could click onto that pump and you could bring up the maintenance records and find out everything you need to know without having to go searching. You can see it right there on Spinview. To change the slide. There you go. So the project priorities, whilst we were carrying out the trial, was to create a digital copy of our infrastructure which can easily be captured and updated and shared. So one of the main benefits of this is you could have Spinview visually on, say, a Teams call, and you could have people across Wales all looking at the same assets, sharing information without actually having to visit site. So it enables remote access to site data and documents, and you're all looking at the same thing and the same piece of kit. So it improves efficiency and it also reduces unnecessary site visits. We've got down there, it ensures faster, more informed decision making in water quality. So it's something that I think out of hours, you can also, if you've got calls from operations but you're not on site, you can log into Spinview, you can have a look, and it can help make a decision faster by knowing what operations are talking about, which piece of kit, etc. Another big driver is the ease of storing data and uploading. So this makes information a lot easier to find because you just go into that asset and you can pinpoint exactly then where the information is relating to, say, for example, that piece of kit. And then also everybody in the business can use this no matter their technical ability because it is pretty straightforward and easy to use. So it's a bit about the challenge. So whilst carrying out the trial with Spinview, there were several challenges which we looked to address. This included making site data more accessible, as data is often kept in paper format on sites in folders locked away. So Spinview is helping to make this data more accessible to everybody in the company, and also finding data on in our internal systems can be extremely challenging. So again, Spinview is linking that data to that asset, which makes it easier to find. Having access visually can improve the efficiency of operations as it makes decision times faster, and it can significantly reduce the need for travel to sites, which obviously reduces carbon footprint. Spinview is also very useful for addressing health and safety concerns, as it can be used to pinpoint exact locations of so for example, if you had a trip hazard on a site, you could actually use Spinview to pinpoint exactly where that is and then share that, say, for example, with the supervisor then, who'd know where you'd been and what part of the site you're referring to. It means several people can come online together and view the same asset without having to travel, making decision times quicker and sharing of information far more generous. And examples of some tasks used by maintenance for planning, tank cleaning, or even just simply if you're looking, for example, to plan a job and do you need scaffolding or not, someone can log in, have a look at the asset, see how much room there is, and decide, what they need in order to plan that job. So overall, it can significantly help to reduce travel time and make decision times far more efficient. And that's me. Let's hand over to Tori now, who will tell you more about the technical side of Spinview.
Awesome. Thanks, Sarah. Find myself. Here we go. Okay. Before I go into the actual project, just a mini introduction. Tori McKenzie-Harvey. I'm the VP of Customers at Spinview. Been with Spinview for around 8 years, and specifically within customer delivery, as well as innovation with our clients. So we very much work in partnership with our clients to develop a lot of our technology to be able to tackle their challenges head on. So the project with Welsh Water, overall the proof of concept took 6 months to complete. However, the trial itself lasted 3 months. We focused on 3 water treatment facilities to carry out the test, focusing across 3 operational verticals. So mainly staff onboarding, stakeholder orientation, and asset health, with a view, as Sarah alluded to minimize travel and therefore operational costs, and reducing Welsh Water's health and safety risk register, and enabling access to silo data. The side effect of this focus being the reduction of their carbon footprint to support their sustainability goals. The project can be split into 3 key phases, I suppose: planning, provisioning, and platform. So on the planning side, which is probably the most important phase, if any project manager will tell you, involves scoping out the project, including the delivery workflow, scheduling. Spinview provided Welsh Water with expertise on what type of visual capture to use and the best hardware to do the job. Our platform is hardware and file type agnostic. What that means is that it enables our clients to select the right equipment for the job that's required. So you're not tethered to a specific device or a specific file type if it comes to uploading information. Welsh Water wanted something scalable, something that they could easily use, so it was repeatable, and just to ensure that their sites were as up to date as possible. So the digital copy of the site was as up to date as possible, low cost, low effort, but with the best results. So with that in mind, we decided to capture these 3 sites using 360 technology. Specifically using an Insta360 camera, the X4. The reason we chose that piece of tech for the capture was because it's easy to use. It's a lightweight camera. Anyone with a smartphone can pretty much use the Insta camera, and it's very economical and pretty much plug and play. The Insta camera also comes with an app that allows you to seamlessly control the camera remotely. So you can download the app either on your phone or your tablet and control it from there. So you can totally make sure that you're not in the image. But even if there are people captured within the image, our platform can blur those people out. So if you're doing anything, for example, that's in the public space, such as some of our clients like TfL, you can like remove customers from the imagery. But that also allows you to ensure, because of the fact that you can view the image, for you to inspect and quality control at capture. So you can view the image that you've just captured, make sure it's accurately and the quality is okay before moving on to the next image. All of the images are actually captured on the app. So once you've connected the camera to your app, you can go into Wi-Fi deprived areas. So if you're shooting within tunnels or things like that, for example, TfL go into the deep tube network where sometimes there's no Wi-Fi. As any Londoner on this call will know, sometimes you can't get connection. You can still use the camera, so it's not going to impede you to carry on taking it. As soon as you're on Wi-Fi, then you can export it. And talking about export, it's pretty easy to export the images from the camera. And as the Spinview platform is a web application, you can upload it directly from the tablet onto the platform. However, there are limitations when you use this type of media, 360, because unlike 3D, so point cloud, so doing a LiDAR scan, where regardless of the station of where you've captured the 3D, the final output, you have the freedom of movement within 3D to any place within the image. The difference with 360 is that it is essentially a 2D image. So your movement is restricted by the positions that you choose to capture within. Hence, the planning before you go down to site is extremely important to make sure that you've planned out your route. So you've got like your floor plan, you've planned it all out. You know what assets are important or what objects are important within the site. So why are you capturing it, essentially? And you've got the checklist to ensure that you're capturing what you need to capture. Provisioning part of it, I'm just going to click through a video to kind of like show a bit of the whole process and the outputs while I explain this part. So we provided Welsh Water with the 360 camera training, our expert in-house specialist, as well as assisting them on site, like Sarah said, with the first capture, just to provide advice on the capturing process and be on hand for any questions. After the site was captured, Welsh Water from their tablet uploaded the images to the Spinview account for secure storage. Our platform provides a comprehensive file management system. So each file that's uploaded to our platform, you've got the normal stuff of knowing when it was uploaded, who uploaded it, but you've also got version control. And you've got a really cool tool where each file gets its own web URL and iframe code, which enables you to really seamlessly share heavy data sets, but also very easily a low-hanging fruit for integration to integrate with other internal systems. So for example, creating something that may be used for onboarding orientation, you can easily iframe the output with all the embedded learning within it into your LMS system, your learning management system. As soon as the images are uploaded, or any file for that matter, they're ready to view and use across our many tools and features. So you can instantly conduct a remote inspection, a site survey, so embed real-time or static data into it, like by creating tags and notes, and then share them with others, create assignments, reports, all that kind of fun stuff, and all in real time. However, one of our limitations is that the 360 walkthroughs. So once you've captured each 360 image, you need to stitch them together to create that walkthrough. That is currently a managed service. So we've got a team that manually create it for you and then deliver it to the platform. Although the automation of that to allow our users to be able to create their own is in our roadmap for early next year. So when you're asking for a walkthrough from your creation, which Welsh Water had. It can take anything from 24 hours to 7 days to turn it around. And that really depends on the size of the site, aka how many images you have. For this POC, we did create the 360 walkthrough, as I said, specifically for orientation. So we embedded other features within the walkthrough, like floor plans and an image gallery, in order for it to be easier for users to navigate, including tooltips. So, for example, that way for water treatment, that way for the offices kind of thing. So you knew where you were at all times if the site was unfamiliar, as well as adding embedded information that a new person coming to the site needed to understand and know. So the final phase is the platform. So once everything, all the data is uploaded onto the platform and the walkthroughs are created, we held a remote user onboarding session, lasted approximately 15 to 20 minutes. Our aim is to build a platform where non-technical teams can use technical data. So in an effort for you to optimize all of the data that your organization has to hand, to make improvements across every work stream. So removing the data silos and creating greater ROI. So as a result, the platform, as Sarah said, is very easy to use. And everyone at Welsh Water has access to it. Don't worry, we do have permission levels and stuff, so things can be restricted, but you're not limited as to how many users you can give an account to. Our license model is not by user, essentially. So with that in mind, to make everything even more accessible for TfL now, for Welsh Water, now that we've got all the data on there, is enabling them to use our AI tools. And that's the next step in our journey with Welsh Water, which my colleague Tom will take you through.
Thank you, Tori. Yep, I'm Tom Lowe, head of data intelligence. My background is data science and data engineering. So yeah, I'm going to be talking about Deep Vision, and that's our Spinview's AI system, and then a bit about how we're using it. So Deep Vision is a multimodal AI system. Multimodal just meaning multiple models, multiple AI models, each utilized and engineered to be used in for a particular task. To deal with the sort of vast range of data that we see, certainly in the water industry, but generally in the built environment, structured, unstructured, temporal, spatial. I've listed a couple of the data types that we see commonly, text, images, obviously the 360 images that Tori was just speaking about. So essentially what Deep Vision is, in a nutshell, is an array of models that are engineered in a way to deal with all the different data types. And so each of the capabilities of each of the different models that we have at our fingertips are seamlessly put together to deal with a task at hand. So if it's image analysis, we're obviously using the model that's best to deal with that. If we're wanting to know the semantics of the text, we're obviously using a different model to deal with that particular task. So the overall goal of Deep Vision is to create a central knowledge assistant, one area that has all the contextual information to be able to give the end user actionable insights. And I'll be mentioning a lot about actionable insights in my talk here, but that's really the end goal. That's the way Deep Vision closes the loop to the end user. So how does it work? Firstly, like any data pipeline with ingestion, ingesting the vast array of data types that I've mentioned before. So all the different data types that we see in the water industry and the built environment. So the second point is really where from a AI model point of view, where deep vision starts. This is where we're tagging, getting the image, carrying out the image analysis, getting the semantics from the text, classifying. This is really the beginning of creating that central knowledge database with the contextual information from the data source that we. So this is sort of the beginning of forming our system. So thirdly, this is where the end user comes in. So the actual user comes in, and this is through natural language, asking our agentic models what the user actually has a problem with, what they actually want to carry out. And so then the fourth part is the system realizing what the user has asked for, and putting together the models that are best suited for that task. So if it's analysis on IoT, we're going to be creating some code to run that IoT data through. If we're doing image analysis, we're going to be running it through the model itself. So it's just making sure that the best models are used for that particular job. And again, as I've already said, the step 5 is really closing the loop and feeding that information that we've got from the analysis and the data back to the end users. This is going to be in reports, visualizations. The best way to get that insight back to the user will be sort of given. And yeah, so that's kind of the last step in deep vision. Nice. So I just wanted to talk about one aspect of deep vision, image analysis. This is the first module of deep vision that was implemented with Welsh Water. So with the image analysis, we're processing vast amounts of images. We're dealing with lots of different scenarios. So those of you on the call that may have been familiar with image analysis, historically, you would train a model to deal with one particular type of image, and you would tune your model to deal with that particular image. But with deep vision, we can deal with faster range of different images. We can classify what's actually in that image. And so that's the real sort of benefit of deep vision. With the image analysis, what we're doing is understanding what actually that is in that image. Through the video that Tori showed previously, you could see that we're tagging and we're understanding what actually is in that image. Once we understand what's in the image and we get that contextual information, we can then start building maintenance regimes and adding that in with other data sources that are available to deep vision to really start getting the end user the actionable insights that they require. Perfect. So thank you, Tori. I know Tori's going to talk about more about Spinview and touch on the ROI.
Yeah, just before I go into that, we're just gonna talk through some real life examples of deep vision in action, kind of like a joint prezzo between Tom and I, collaboration. So the first one is from another large infrastructure client. which was mainly focusing on data silos. The problem here that we were trying to solve was through Deep Vision and our dashboarding product, their siloed data problem. The client used 3 different asset maintenance systems due to the need to keep historical systems alongside the new, more efficient systems, due to the lack of understanding of the relationships between the assets and how turning them offline would impact the network itself whilst they were upgrading everything. In addition, you had the combination of both structured and non-structured data to deal with, and slightly varying unique reference numbers for the assets, because within the organization, different teams talked about the same asset in different ways. So that sounds familiar to some asset management people on the call. So they wanted a central solution to amalgamate and harmonize all of that data so that they can see the interdependencies between the assets, kind of providing a holistic view of the maintenance and renewal schedules, so they could really understand what older systems they could turn off and their impact across the network, so that, you know, it doesn't all shut down, essentially. Tom will take you through what we did to support them with this. Over to you, Tom.
Perfect. Cheers, Tori. Yeah, so essentially what the client was requiring was, they had a lot, as Tori said, a lot of different databases, a lot of free text inputs, which is sure everyone's come across free text inputs, which as a data scientist is challenging. So what they really want, what the node graph shows on this slide is the assets that are sort of have a lot of circuits hanging off them, and some of the nodes you'll see don't have lots of circuits hanging off them. So when a certain asset was taken offline, they really wanted to figure out what was the impact on other assets and the other circuits that were connected to it. And this node graph helped them to understand which assets were sort of central to that particular area, and they had to really think about if they were bringing a certain asset offline, they had to really think about the planning that, because obviously it would have a huge impact. It had a lot of circuits that were connected to it. The other thing we did for them was they wanted to know, could assets actually be maintained? So did they actually have enough spares? So if it had to be replaced tomorrow, could they go ahead and do that? And so that's what the bottom right graph shows you.
So most of everything that we kind of do, we try to put in a RAG color system. As humans, 80% of the way that we communicate is visual. So making sure that you can simplify complex data, and if you can use a color system that's pretty unique or wide, like red, amber, green, you can instantly see what needs to be actioned. So you can see that there with the spare parts, where all the ones in reds are ones that are low in stock. They do need replenishing, and you've got assets that are going to be requiring them. So you do need to action something there. Once you go a bit deeper into each one of them, you can then see exactly how many are left and what the timelines are to be able to secure replacements and stuff like that, so that you can actually have a more planned approach to your renewals. The next example is alongside actionable insights. So this client is actually based in the US. They are part of a municipality, their Parks and Recreation department. Their key challenge here was identifying and managing illegal dumping within the parks. So they did have CCTV cameras in some of the areas in the parks, and they were manually trying to identify illegal dumping and try to figure out the patterns, working with the police with that. However, this process was manual, so therefore highly inefficient, time-consuming, and costly. From a cost point of view, it was not just being able to having to sit down and look at the CCTV camera for hours on end, identify when a perpetrator has come in, identify the license plates, and then fixing the issue that happened with the illegal dumping. But then being able to send all that information to the police, and possibly actually not being able to find people because they were not able to be that reactive. So what they wanted from us was a centralized place where the system could automatically identify the perpetrator, so they didn't have to go sifting through CCTV to find that, quickly identify it, be able to issue a report instantly to the police, but also importantly, trying to find patterns in that. So what days, what times is this happening? Is there a pattern to it? Which we did find, and therefore being able to put preventative measures in place. For example, police presence at those times, and it did reduce the amount of legal dumping as a result. But Tom will take you through exactly what we did with Deep Vision and the dashboarding system to solve that.
But yeah, so this is really an example of our previous examples are all sort of human in the loop systems. This system was very much sort of automatic. So you can see there that we used image analysis to identify when a car was fly tipping, and also to get the number plate. So that number plate could be forwarded to the police department, and so they could take action on the fly tipper. So this very much uses the image analysis module. In addition to the image analysis thing, and that sort of like automatic sort of, okay, you fly tipped, we're forwarding your number plate and the evidence to the police department. We also wanted to understand if there are any patterns into fly tipping. For example, presumably these people were going to be fly tipping at night when it was dark, when there was less people around, and that's kind of what we found through the analysis. So this was quite an interesting project because it was both sort of, we had the automatic side of things, and then we also had the analysis and your sort of human in the loop giving actionable insights to the police department via a graph that we're sort of all used to from a data science point of view. So yeah, it was super interesting, this project. It was a really good illustration of how we're sort of merging AI and cutting edge sort of agentic models with traditional analysis that we're all probably very much used to.
Mm-hmm. Thanks, Tom. Yeah, so just to summarize, at its base levels, Spinview is a remote visualization intelligence platform that lets you access, inspect remotely, cutting down on travel, breaking down silos. But as Tom just went through, that's just the starting block of what it can do. With Welsh Water, we used lightweight cameras. As I said, we're agnostic with that. You can use any hardware, any type of file type. So the same kind of tools that we've used with 360 in our platform, you can use your point clouds, 3D models. You can have drone images on there, orthophotos, full BIM models. But all of them, you can use the tools on the platform with, and that includes the image analysis and the other deep vision modules. The aim is that teams can collaborate in real time, track progress, generate reports with the help of AI, and be able to ensure compliance at all times by using a centralized system. So we can either integrate directly with the systems that you currently use, or be the front end and integrate all of your systems in one, or at least feed that data in so you've got a central place to be able to get that data and analyze it to get your actionable insights. So what does that all mean in terms of your return on investment? So our Vision license plan starts from $250 a month. So that's the starting license. We do have structured license table. That starting license includes everything that you really need for a proof of concept. All of our license plans include unlimited users because of that mission that we have of making data accessible to everyone, to remove data silos, because we really believe that you having access to the right data empowers you to make smarter decisions and faster ones. And as well as unlimited uploads. You're limited to the number of sites that you can have. So that's kind of like that, and the amount of storage is where the license is kind of judged, the fee table. 10 sites though, just for, I don't know if context is the right word, but is not necessarily a building. It can be a couple of buildings within a site. So a water treatment facility, for example, Court Farm, they had about, I think it was 4 or 5 buildings within the complex. That is one site to us. So one place that does something. One pin on the map for a better description. And 500 gigabytes of storage. The storage also goes up as you increase your license fee. You get access, as I said, to our IoT service, the observability dashboards. Again, further fees may be incurred if you're needing us to provide you with hardware or the API connections to bring into the dashboard. If you've got existing dashboards already, whether that be like something like Power BI, you can integrate that in directly, so you don't have to duplicate your work. If you've already got your energy dashboards for each one of your sites, for example, you can integrate that in, see that in one place, and use our IoT tools to get insights from that directly. We're all about not having to do it twice, that's for sure. As I mentioned earlier, unlike other providers, we don't charge per user, which means that you can democratize your data across the entire organization. So you can empower everyone in your team to have access to this and act on the insights. So as I said, the $250 a month as the starter pack includes this insights. If you wanted to include more, it's just shy of £10 a month per additional site. Once you hit a certain amount, then you get economies of scales as you progress up. So the more sites you have, essentially, the more cost effective the platform is. In terms of the direct cost savings, we were able to directly attribute and calculate figures of savings made to the reduction of the site visits. So that's kind of like what I'm going to talk through. Welsh Water spent approximately £150 per site visit. So that's essentially like your petrol and time away, with approximately 10 site visits per month. So with that in mind, there's about 500% ROI, so return on investment, based on the base license platform fee. A side effect from the direct costs, as I mentioned at the start, is the carbon savings. So on average, there's about 50 kgs of carbon saved per visit, so an average of 500 a month. But to make that more tangible, that's equivalent to planting 25 trees a year. This side effect of the carbon savings was particularly important to Welsh Water because they have a big business organizational drive towards sustainability. Finally, as I've said before, our mission is to make intelligence accessible to everyone, bridging the gap between complex systems and human decision making. So Spinview exists essentially to unsilo building data specifically, to make it easier to use. So we help you with reducing risk and operational costs. As you can see, achieving ESG net zero targets, but over all of that is making it easier for you to make faster, data-driven decisions with confidence. Where the platform is like beyond really a digital twin, it has a human-first approach. So Spinview is like an intelligence layer that turns complex data into clarity, empowering every user from frontline teams. So the platform you do, unlike the Insta app, you do need to have Wi-Fi to use it, but you can use it on a platform. It's fat finger friendly. And you can use it in real time and monitor your organization. If you think of it as the platform is giving your building a brain, essentially. That might be a little bit scary comment, maybe. But it is essentially that. It's giving you the insights that you need to be able to make the right decisions. And we envision a future where data drives every decision, optimizing efficiency, sustainability, and safety across the built environment. And with that, Leah? Sarah?
Oh, Sarah, it's a little hard to hear you.
Can you hear me now?
Yes,
Yeah.
that's a lot better.
Yeah.
Thank you.
Okay. Okay, so it started with what went well. Training was really quick. Using the 360 camera and the mobile app, the app could be put onto your phone or your tablet. So it was instant. You could see the pictures you've taken straight away. So you were able to capture very efficiently and upload to Spinview with minimum support. So once storage had showed me how to do the first one, the rest were fairly straightforward. And then the walkthroughs which were produced were very valuable to quality teams and for onboarding for new employees to show them around. And it was very easy to demonstrate how it could save time, cost, and also the health and safety benefits. Like I said before, really helps you to pinpoint exactly where you've had issues.
So in terms of the obstacles and challenges, and we do obviously find this quite a bit, especially in larger infrastructure, is restrictions on being able to access third-party applications. However, our platform has a plethora of ISO certification, so that really does help. And we just are able to pass cyber security and tech due diligence. But that if that's not done in advance to the proof of concept, it can have an impact on the delivery of the project. So making it easier for Sarah and the team to be able to upload onto the platform. So we did have those challenges with Welsh Water. We quickly surpassed them, but it is something that does happen with large infrastructure because, rightly so, you've got restrictions on people using third-party applications. The data capture itself does operate outside of Welsh Water's internal ecosystem. So Spinview is now kind of part of it, but the capturing process, we're a software company, not a hardware company, and it would be another step further to be able to bring, for example, the Insta camera into Welsh Water's ecosystem. However, in saying that, the data that's captured resides on the app itself. So it's that unique user's data, and it's your images. Insta also do not own it, the same as Spinview. So it's not shared with anyone, and they have also got restrictions to that. So again, passing cyber for that or tech due diligence is pretty seamless, but it is something to bear in mind that it's not as easy as the Spinview platform or your hardware to necessarily be part of your ecosystem. It just takes a little bit longer. Integration, full integration is required for large-scale adoption. So we have just completed the proof of concept. We're about to move into rolling out some of the AI tools. We find that for large infrastructure, again, that phased approach is step by step and starting with one team. Although it's slow, it allows you to ensure that you're aligned with that customers or clients' way of working and their ecosystem, so that we can deliver something that's custom to what that client needs. But once it's adopted, once you've passed those 3 stages, essentially, it is very easy to then fully have full adoption across the organization. We found this exact same approach with Transport for London, for example. We started very small within the Piccadilly line upgrade team, and it's now expanded across all of construction for Transport for London, customer operations, and it's the exact same solution, just replicated across the other functions within TfL. So the adoption side, once you've done the hard work of being the first team that uses it, everyone else gets the benefits, essentially. Yeah, so that last point and extra steps for transferring data, that is more to do with the camera and being able to upload. Oh, no, that does have to do with the upload, wasn't it? Sorry, Sarah. So in order to be able to get the data uploaded, we had to execute some other data transferring protocols in order to get it up to our platform for the first site capture. And then after that, we had sorted out being able to upload directly to Spinview. It wasn't, I don't think it was necessarily that much a challenge. It was just a little bit annoying, wasn't it, Sarah? More than anything.
Yeah, to be honest, the ones I did, I was able to upload them straight away. So
yeah.
I wasn't there for that. So overcoming challenges. So Spinview provided support in the walkthrough creations. So actually stitching everything together, there was plenty of support, and with IT as well, and how to overcome the barriers. There were some workarounds established for data transferring during the trial. I'll admit the easiest thing to use was a tablet in order to get all the data and then upload. And then it just highlighted the need for the formal IT integration process for smooth rollout. So basically get IT involved from the start, and then you won't have any problems.
Yeah. Improvements for further adoption. So I think Tom took everyone through the next steps. Sarah just pointed out earlier engagement with IT would just streamline the integration process. We have only trialed it with a small user group. The next step would be a larger scale, exploring a single sign-on process for Welsh Water just to improve security, so with 2-factor authentication. And finally, empowering Welsh Water with the AI modules, which is the next step. And we're starting off with image analysis, as that one has immediate benefits for asset health and being able to identify objects within the scene, creating automated inventory, and over time also being able to predict asset health as well. And then we come to more of like a discussion piece. I saw actually a couple of questions actually pop up about this. So how can AI help the water? But the question was more along concerns around AI. AI helps, really does help with predicting when assets will fail, how we can fix them before they happen, because it pulls from across multiple data sets. So, and the more that you feed it, like a child, the more that it learns. So it can, over time in particular, and the more data that you're feeding it, can more accurately predict over time. And it really will cut your maintenance costs because you'll have more planned effort, and you'll be able to control your budgets better. However, I suppose there are 3 areas of like concern with AI: data quality and integration, trust and transparency, cyber and privacy. So with data quality and integration, just like with our platform, AI is only as good as the data that it uses. So bad data in, bad output. And water networks can often be inconsistent and siloed and incomplete. Hence, our focus in the early first stage of unsiloing that data, exposing it, and centralizing it so you can harmonize it all. But poor data quality fed into the model will obviously impact the accuracy. So that's the way that we try to mitigate it. I don't know, Tom, if you wanted to weigh in on that one.
Yeah, definitely. I think, yeah, there's exactly it, really. I think AI and sort of it opens up like a vast amount of like new data sources that we can have access to, like PDFs, text, your like unstructured data that before would have gone into a Dropbox or gone somewhere that would have been very hard to have access to and do analysis on, from a sort of a programmatic point of view. So what really changed the game, in my opinion, is we've got access to so much more data now that we can feed in, and so much more context that we can feed into to our models, and we can use. But exactly as you say, Tori, we need to be super careful about the guardrails that we put on and the security, and that's what we've spent so much time doing with Deep Vision, in making sure we've got the guardrails and the security in place. So we're making sure it's safe, but also it's usable, and gives real value.
Yeah. So the second concern, the trust and transparency aspect. So whoever uses the AI tools, and I'm sure many of us on this call have used Copilot and ChatGPT and stuff, you need to understand why AI makes certain recommendations. So if an AI model is ticking the boxes, basically, or if there are any areas that are slightly grey, that can lead to hesitation in using their recommendations for critical decisions. And bearing that in mind, on depending how you ask a question to Chat or to Copilot or the other ones, Gemini, you will get different answers. So the way that we have circumvented that issue with deep vision is by creating a front end to that search function, which takes the user without them knowing through a, I think it's 4-layered protocol, where we're kind of like forcing you to ask the AI tool the question in the right way for you to get the right output. Right, Tom?
Yeah,
Right.
exactly. And yeah, exactly that really. And making sure that we're using the right model for the right job. Exactly as you were sort of saying, really. So we're not going to be putting IoT data and through a neural network because an AI model, because it's just fundamentally the mathematics. You just wouldn't use a system for that, a neural network for that. We've done the engineering to say, okay, well, we're not going to do that, but we are going to generate some Python code or something, and then run your IoT data through that, and then we're going to get reliable feedback, reliable actionable insights from that, and we're going to be reducing the hallucinations because we've done the engineering side with deep vision.
Just for some other people on the call, did you want to explain what a hallucination is when it comes to AI? Tom?
Yes, yeah. So essentially, we've got to realize that transformers and neural network fundamentally are predictive bits of maths, really. And so we're not, and so essentially, because it's obviously predictive, it's going to be giving wrong answers. It's going to think they're right. It's going to be giving you the best answer that it thinks, but they still can be correct. They still can be wrong, and we've all experienced that. When as soon as you start, it starts giving you an answer. You're like, wait, this is just off. So yeah, this is what we've spent so much time trying to deal with with deep vision.
Yeah.
Through the architecture that Tori was talking about.
And then the final one is cyber and privacy. So connecting sensors or cloud platforms. So when you're trying to integrate the other systems within Spinview or your sensors that you may have insight into our cloud as well, can lead to exposure for cyber threats. So ensuring that you've got secure data handling and compliance, especially with regulations, is essential for large-scale adoption, which is why we have gone through the pain, and it is quite painful, of multiple ISO certificates in order to ensure that we are compliant with regulation, including data protection, but also ensuring that our data handling is as secure and as robust as possible. And Tom is actually one of the architects in making that happen. So I'm sure you've got a lot to add to that one.
Yeah, I mean, definitely with the guardrails is, so I spoke a lot about contextual information, and models, especially agentic models, are going to be trying to grab context from wherever it wants. So we've needed to make sure that we put the guardrails in guardrails really securely in place to make sure that model is only grabbing Welsh Water's data or TfL's data, for example, to make sure there's no bleeding between our customers. Actually,
it's a good example. I didn't think about that with TfL. They recently had a cyber threat. I think it was earlier this year, or was it last year? I can't remember. Where they had to close down all of their systems. Ended up being a 17-year-old, something like that, in his house just trying to test it. But our platform was not at threat because of the guardrails put in place. So that's a really good example of how we have tried to be as near to bulletproof as possible. I mean, someone's always trying to figure out a new way to get in. So that's why we conduct regular checks on making sure, one, that we're up to date with the latest way of people trying to commit cyber threats, and just testing our platform regularly as well. So with that in mind, that we've kind of tried to mitigate as much as possible the concerns that some may have with using AI. Maybe, Sarah, we could look at like the 3 ways that we were discussing on how it could be used within Welsh Water and other water companies. One of them is like thinking of asset health, specifically, predictive maintenance. So by using AI, you can monitor equipment health, and you can move away from being reactive fixes to something more smart and more predictive maintenance, keeping assets running efficiently and reducing downtime. So like the AI modules can focus when an asset's failures before it happens. And then condition-based monitoring as well, where it's scheduling replacements, fixed intervals and that kind of thing. And that we kind of showed with the example early on in the data silos of how we centralized all that data, and now the client has visibility and we're able to report on when a renewal needs to happen, when's the next scheduled maintenance, and whether you've got enough to be able to fulfill that in advance before you go down there and find out that you don't have any spare parts. I don't know if you wanted to add anything more to that, Sarah?
That's just sort of the next sort of phase that we're looking at now, because we're sort of looking at phase 2 of the project, and just what Tori said really around asset health and how we can become more of a preventative maintenance, predicting things rather than always being reactive.
Yeah.
So yeah.
Yeah, I mean,
what he said. So hopefully the AI can help us. Yeah.
Yeah, exactly. I mean, it can also talking about system integration. You can integrate other systems within it, and then use the AI tools that the platform has to interrogate that. So as I mentioned before, like I know that you guys already have like energy dashboards, for example, for the sites. So once those are integrated in, the Welsh Water team will be able to interrogate that data alongside, your asset register, for example. So you can have a more contextual understanding of the site and what's required. I mean, Tom, you know more about the dashboarding integration than I do. That's your day job.
Yeah, definitely. I guess the integrating so dashboards generally come from the structured IoT data from, if it's energy, it's going to come from an energy meter. Now we would do some processing on that data to be able to give you the actionable insights that you want. So we're not just going to be displaying the sort of raw data, we're going to be doing some work to that data before we're displaying it back to you guys as an end user. I guess the thing about, like, it all goes back to actionable insights. If you've already got those dashboards and you're already, actioning on the insights that you've got from the already created dashboards, we're not in the business of copying things over. We would maybe look at a different aspect of the energy. Maybe we would do some more analysis and then give you a dashboard on, to illustrate on a different sort of use case, really.
Yeah. And then I think you mentioned it earlier, Sarah, the whole like you've got hard copy stuff on site in manuals in a cupboard that's locked. So digitizing that kind of stuff is also part of the process, and that's why I think the platform actually really leverages beautifully with aged assets. So not necessarily new builds where you have a lot of your building data in hard copy. So the process of digitizing that data is also one of the things that we do is that phase one, digitizing it. If it's something, for example, like an energy meter that you're going down to site to take the readings from, is working with you to make that smart. So it's automated, so you reduce the need to go down and you have that information earlier on, that kind of thing.
Especially with sort of like with energy meter, the value of the data that you get decreases fairly quickly with time. And what I mean by that really is, energy from 10 years ago, it's not that much, it's not as valuable as energy from a week ago, because I can't action, 10 years ago, the site will have changed quite dramatically, presumably. You'd have got different motors installed and things, the sort of shape of your energy assets will have changed. But what it's really good at is we can get a baseline of the energy, for example, and we can see how it's improved or how it's not improved. So
yeah, and also then using those data sets against other data sets. So a great example is we did a piece of work for a client who wanted to understand more about the well-being of their staff within the environment. So we captured the air quality in their offices, correlated that with their absence data, and their occupancy data as well. So basically who's in. So you had sensors that are saying who's in the office, at what times, that kind of stuff, and absence. And what we found with them was that there was a really high particulate matter in one of the floors in the building. And it so happened that it correlated with high absence of the individuals that were in that part of the building. And this is where the visualization comes into play, contextualizing what you're seeing. What we could also see, what image analysis pointed out, was that actually they are right next to printers who are exposed. They were not within a separate room. So they're out in the very closed office space. And that was what's causing the high particulate matter. And the employees there were going off sick because of coughing, so respiratory things. But without you being able to correlate that visual data set with what's actually going on, understanding the air quality level, and then your absence data, you probably never would have figured that one out, apart from the fact that maybe these guys go away a lot in that part of it. Maybe they're lazy, I don't know. But you wouldn't have necessarily thought it's the printers. Yeah. I mean, I didn't. So.
Such a good example of, you need the context to be able to get the actionable insight, and that's what we can get with deep vision. Because exactly. I'm sure if you went to a site, there would have been, and you interviewed people, there would have been, a lot of ideas. Oh, maybe it was this, but we actually need to digitize that, and so we can empirically say, it was. It was XYZ because of that reason.
Mm-hmm. Yeah, and another one actually was Transport for London. we captured the air quality between 2 stations. Because it's a very big push within TfL, just like with Welsh Water on sustainability, your carbon footprint, the net zero. So we're working with them a lot with being able to visualize all of the data, the sensors that they're installing. And we found that we mapped this out against the scheduling of the trains and the engineering work. So work on the tube, the tunnels themselves only happens when the trains are not working, obviously, because you can't have a live piece of track. So it happens in ungodly hours. So between 2 and like 4 or 5 a.m. No, sorry, 1 and 5 a.m., something like that. And what we found was that the particulate matter within this section of tube was really bad early on in the day. So we started. This is when we were doing a static data capture. So it wasn't through a sensor that's constantly feeding data in, but one that was on an engineering train. So what we found was that, because it's part of a proof of concept. So what we found was that the particulate matter was really high at the beginning, and then it went green. And then when we did the second pass back, it was green on the other side. And when you correlated it against the other data of the, the train schedules and the engineering works, what we found was that the particulate matter was high between the hours of 1 to 2. So at 2 o'clock in the morning, it started going down towards levels that are considered optimal. And that was predominantly down to the fact that the trains had now gone to sleep and essentially the dust was settling. So it helped inform TfL of getting the engineering, the guys that are going down to track, to do most of their admin beforehand and only go down to track after, so after 2, essentially. And strangely, there was one anomaly in the data set where this particular part of the track, it was like the air quality was really good compared to everything else. But when you correlated that again against the visual, and not even TfL like clocked it until we correlated against the visual, was that part of the track, there was a disused station. So there was an outlet for the particulate matter to go away from, making that section much healthier because it could disperse into the disused station. And again, it's that using all of the data available to you to create better insights and understanding of your infrastructure and how it affects the people that work in it. Cool. And with that, one of the final slides, everyone will be happy to hear. It's just some of the feedback, both from Welsh Water and our other large infrastructure client that is as close to a water company as we can get in terms of, well, at least with Welsh Water, the number of assets that they actually have, the estate that they've got. And I think it's now over to you, Leah.
Perfect. Thanks, everybody. Really great presentation, and that was a really interesting discussion about AI and how it can help the industry. So thank you so much for that. It was really good. I am just going to stop sharing the presentation now so that we can go into the Q&A portion of our session today, and you can see our lovely presenters a little bit better. We've had a few questions in, but do make sure to keep putting them in the chat as they occur to you. You're allowed to keep putting them into the Q&A. That's absolutely fine. And we'll try to get around to them. So first up is one from John, who wanted to ask, how is the system linked to work and access management systems to create and issue work orders on specific asset components? Are these graphics linked into the asset registers?
I can pick.
Oh. Yeah, okay, take it.
I was just, so wasn't linked into a asset management system. We were dealing with generally historic data for that system. And yeah, 3 asset registers that that we had to sort of get into to one sort of usable asset register database. Yeah.
Yeah, so just to expand from that, in general, the integration of any other systems that our customers have is pretty much on a case-by-case basis on how we do that. So the Spinview platform itself can integrate with other systems as long as those play with other third parties, that is, caveat. And then you can create all of the outputs from the Spinview platform, so your work orders can come from there. But if you want it the other way around, again, that can happen, but it really does depend on what system you're using and whether they play well with others as well. So you can, so from one of our other clients, for example, a lot of the visual data and some of the historical stuff gets fed in through a data exchange, a two-way communication between their asset register platform. And it's both a simple CSV file with the data that's been pulled directly into their asset register, into their family tree of the asset. And then all of the visuals that they've taken get taken across as well through those web URLs. So you can view them when you're in the other application. When it comes to, for example, the LMS system at TfL, that again was a simple iframe. So you're just taking the iframe code from the image of the walkthrough on the platform and embedding that into your LMS. So that's like the easiest way, the lightest one. And then that two-way communication, probably the most complex one. But that does require for us to sit down and see what the systems are, because it really does depend on the other system and whether they're happy to integrate with us.
Perfect, thank you. So you mentioned that there's some systems that you might have more problems with than others. Are there any ones in particular that kind of come to mind that you might struggle to integrate with or have any issues like that with? Or is there any kind of preferred system that you prefer to like work with, that you would recommend that a company has?
Well, like Microsoft is pretty easy to integrate, so Power BI is very easy. Quite a lot of LMS systems are very easy to integrate in. I'd say it will be more the larger engineering software platforms that will be not necessarily it's more complex. It's whether they want to integrate with us, because they, in all honesty, can sometimes see us as a competitor, even though we're not. We're not a design, like 3D design platform. It is much more operational than that. So it's more like the phase 3 of construction, whereas most of those platforms focus on the design and planning part of it. But once they get over that understanding, then they understand that it's okay. So yeah.
Perfect, great.
Definitely,
thank you.
And definitely in terms of sort of like asset management, I think a lot of the problems that we actually have with integrating with our customers and partners are actually sort of business related business related and not, technical related, if that makes sense. So it's actually are we giving the security rights to have access, read access to your data, and bring it into the Spinview databases so we can do the analysis and all that stuff is the only thing I would add on that from a
totally
technical
agree,
point of view. Yeah.
Great, thank you, Tom. Perfect. So next question is, if it'll pull up for me, bear with me. Not opening for some reason, bear with me, sorry guys.
That's okay.
I'll go from the chat. Let me just grab it up. So the next question from Ian is, does the Spinview platform have any way of storing and managing laboratory test results for air or water compliance reasons, for example, air quality samples or Legionella samples?
The simple answer is yes. So yeah. So you can both store your structured data, so any reports or anything that you have, and then you can link that in, and we could create observability dashboards so that you can see that data and then use deep vision to interrogate it to help you with the insights from it. And that part of like the report generation and looking at the data from your test results, that you can customize as a user on the platform. So how you want to see it and what you want to see. And at any time, you can also, depending on your permission levels, download the raw data as well.
Perfect. Thank you, Sarah. And is this more for water authorities, for example, rather than surveying contracting business, in particular drainage surveying?
I mean, I'm sure water companies, authorities could use it from a compliance point of view, I suppose, 100%. But we also find that predominantly, as I explained before, we're more a platform for operational use. So it's a lot more like facilities, maintenance, the operational business units, you know, training, development, asset health, that kind of thing, where it's when you're trying to optimize as much as possible your OpEx spend, which is sometimes a lot more, what's the word I'm thinking of? Like a lot more difficult to do than your CapEx spend, essentially. But you're leaner. You've got a very, very fixed budget. And you're just trying to get the most out of it by reducing redundancies that you don't need to do. And if you make your operation smarter, and by smarter, I mean digitize it, you can find those savings both in time and cost so that you can spend the money in other things that are more important, like your people to do the job. Absolutely.
That's great. Thank you. So I'm not sure whether maybe the question was referring to water authorities within the water companies themselves, and maybe I think Mandy might be a surveying like contractor business that would work for water companies. So I think she meant would it still work well for kind of for a contractor working with water companies?
Definitely would work well for a contractor. In fact, a lot of TFLs, tier 1 contractors, use our platform for that. So as long as, for example, Welsh Water give access to their third parties, for example, they could look at the drone images to conduct roof surveys, or being able to actually conduct a visual survey of a site without having to go down, so you can bid on it more accurately, for example. So it just removes the amount of times you need to go down to site to do that kind of stuff. So as long as the water company is happy with you having access to that data, which is kind of like the point of the system, you will be restricted, so you won't be able to download the data, for example. Yeah, no, it can completely help third parties as well.
Amazing, thank you. Next question from Shula is, how does it work with adding additional assets once we are live? How are changes managed?
Could you repeat that again?
Yes, sorry. How does it work with adding additional assets once live? How would you make those kind of changes?
Yeah, so there's a few ways you can do that. Like if you've got version control for every single site. So in terms of the visual capture, like with any visual survey, you need to make sure that your workflow is consistent every time you go down, hence the planning and marking it up. It's the same thing with 3D capture. You want to do, or drone capture, you want to do the same flight path or workflow every time. So you've got like for like. So as long as you're doing that every time, you'd use our version control function for you to override it with the latest one, but still with the ability to see the historical. And in fact, over time, you can then get a really good picture of seeing how your infrastructure has changed by using the time-lapse function. So you can go back and see what it was like. And in fact, that's the same thing if you were changing anything within the infrastructure and you had another 3D model, let's say, of the new thing, you can overlay it against the old and see the deviations, and you can do the same once the construction is completed and you take a capture of it. You can then overlay that over the design as well, and again see the deviations to see where it's changed from what you signed off on, for example.
Great, perfect, thank you. That sounds like a super handy feature of the platform. So Sarah, coming back to you, we had a really great discussion earlier, and thank you, Tori and Tom, for leading on that about how AI can help the water industry. Did you, Sarah, all experience any blockers within Welsh when kind of trying to push this project through? Was there any kind of, did you face any challenges with bringing AI into the business in any way?
Well, at the moment, that's sort of what we're going into next, so I can't really say yet.
Oh, I see. Sorry, so AI is the next steps for you. I see. Yeah.
Yeah,
no
because
problem.
we've done we've done phase 1 of the project, which is like proof of concept and everything, and now we're going to be looking at starting phase 2, which will hopefully start using the AI function of it. So it's something that we get approached about, because I did mention at the start that as the innovation team, we always get asked on what technology do we know about, which involves 3D imaging, digital, AI, and everything. So there's a lot of interest in it. So everybody wants it, but it's just getting it past IT, cyber, and everything like that.
Yeah. A lot of nervousness still in the industry about
but it's really it's always one of those hot topics, like when you have a meeting about innovation and what people are interested in. So this is why we're so interested in Spinview, is because it kind of covers what everybody wants. Like when you go across all the different departments and ask them what they're interested in, Spinview seems to tick all the boxes.
Perfect. And so you've had some really good feedback from team members that have been trained on this then so far?
Yeah, they were quite keen, and they want to move on. They want to go into phase 2 of it now. So
perfect.
Yeah,
great. Well, I think that about brings us to the end of the session, unless anybody comes out with any final questions in the last 4 minutes at all. Or Tori, Tom, Sarah, if you wanted to finish up with any sentiments at all before I dive into the closing statement.
No, I think I'm talked out.
No problem. 2 hours. 2 hours isn't that much. What are you talking about? Perfect. So thank you so much again for all the work that went into today's showcase. I think it was a really poignant and interesting topic, and you delivered really well on it. So thank you so much. And again, thank you so much to all the audience that joined us live today. We will, as I say, be posting this on our platform, the recording of today's session, along with a written case study. So if you are interested in that, all let us know in the feedback poll as well, and I'll make sure to send that to you once that is available. Any colleagues as well, feel free to have them get in touch with me to receive the recording and case study once that's ready. And the link to the platform is just in that message above there for you to go and check out now. Once again, if you could just make sure to answer the feedback poll before you do leave today, it would be really, really great. It really helps us shape these sessions and make sure that we have really informative presentations like today in all of our sessions. So yeah, thank you so much, everybody. Thank you again to the team, and I hope you all have a lovely rest of your day.
Thank you. Bye.
Thanks.
Thank you, everyone.
Bye.
Thank you.
Bye.